Okay, so today I'm going to walk you guys through some code that will allow us to create some different 3D objects. So today we'll mostly be working with spheres and a surface plot as well. And this will allow you guys to complete the guided practice for this week, where you'll be creating a topographical map of the Earth and then rotating it for a little added effect. So to get started, I created a breakpoint in this line of code, which means when I run through it, it's going to run these 3 lines and then stop here at this line of code so I can talk you through each step. Alrighty. So it's run these bits of code, just clearing and closing everything, and now if I hit continue, or if I run step, it's going to run my next line of code and create a figure, and then if I step through again, it's going to add a sphere to my figure right here. Okay, so what it did was it created a sphere. So the sphere function, what it does is it generates a 3D spherical object, and the argument I pass to it is just telling MATLAB that I want to create a sphere with 50 faces. So you can see what that looks like here. Okay, and then just continuing to step through. So I am going to generate a new figure here, and then create another sphere. I'm actually going to minimize this window so that my figures don't stop my recorder anymore. So just bear with me while I get that oriented. Okay, cool. So I'm going to step through, and this, instead of creating a sphere with 50 faces, it's going to create one with 20. So if I step through, you can see here that the surface looks pretty different from the one we just made. So the faces are a lot larger in the one we just generated versus the one with 50 faces. And so this is useful if you want to, for example, give each face a different color. You can change the size of your faces to look more or less discrete. So that's one thing you can do with that. Okay, so the next thing, I'm going to generate variables x, y, and z by setting it equal to a spherical object. So what this is doing is just creating a set of variables in my workspace that are essentially coordinate points for my sphere. So these are all my x values for my 3D object, and then the same with y. And z is the same. So it's just generating objects, and then I can manipulate those using the surface function. So I'm going to generate a new figure here, figure 3, and then the surface function, what it does is plot a surface based on points that you apply to, or points that you provide to MATLAB. So I'm going to go ahead and pass those matrices into the surface function, and you can see what pops up. So it's just the same as the sphere we just created with the 20 faces. So it just essentially remade the figure that I had just done using the surface function instead of the sphere function. Okay, and then I'm going to step through again and hit hold on. So I'm going to generate another sphere on the same plot. So this one is going to shift the position. So you'll see here that I have my x, y, and z values that I had obtained up here, and I'm just going to shift everything to a different x, y position. And so this one will be centered around 3, -2, 0, and this plot that I'll make next will be centered around 0, 1, and -3. So I'll just step through that, and you can see that there's another one here. So this one is centered around 3 in x, -2 in y, and 0 in z. So it's centered around the same z. And if I step through again, it'll add, it'll add another plot here, which is at different points, at different z positions than the other 2 that we had just made. Okay. So these spheres are all the same size, you can see. You can also move them in the plot. If you click on this little arrow here, you can rotate them, give yourself a different view of your plots. You can also zoom in and out or pan if you want to change the positioning. Okay, so stepping through, I'm going to create a new figure and then generate some spheres of different sizes. So I'm going to use the same positions as I just used, but my first sphere is going to be of a larger size than the other two. So if I step through, whoop, there's one, okay. So it's generating my spheres, and I'm going to rotate this so that we can actually see it a little bit better. Whoop, there we are. Okay, so now you can see that one of my spheres is bigger than the other two. So I multiplied by 2, so it should be about 4 times as big as the other spheres, because it is increasing the x, y, and z values by 2. So in each direction it will be doubled, so it should be 4 times as big as the one we just made. Okay, so then stepping through this code, we are going to create a new figure file, go figure, and then what we're going to do is we are going to use one of the previous spheres that we created. So it's similar to one of these, except I made the dimensions multiplied by 5. So if I step through, you can see what that one looks like. It looks a little funky because it's at a weird angle. So I have this here. So it should be going, oh, there we go. Okay, cool. So there's our sphere there. And then I am going to use the color map function to change the color of the sphere surface to a default color map that MATLAB provides. So I'm going to use the one Spring. You can use, you can search for different types of default color maps in the documentation. You just type color map, and then there'll be a help page that has some different defaults that you can use, or you can define your own, which we will do today in lab, or which we did for the previous lab that you just completed. Okay, cool. So I changed the color of my sphere, and now what I'm going to do is I'm going to define this variable direction. So what this matrix is referring to is I'm going to use this variable to tell okay, let me just step a couple lines down here. So in this line of code, I am using the rotate function, which has different arguments. So S is referring to my object, so that would be my surface object here. My direction is telling MATLAB which axis I want to rotate around. So you can either, so this would mean, if this was 1 here, it would mean I'm rotating around the x-axis. If this is 1, it means I'm rotating around the y-axis. And then what we want to do today is rotate around the z-axis. But you can play around with this if you want. And then I think you can obviously rotate in between axes. So if you want to rotate along a line, I believe you can also do that. So if it's in between one of those, you can play around with the direction of rotation. But today we're just going to rotate in the z direction. And so what we're going to do is create a loop in this next line of code that's going to go from 1 to 50. And you can play around with the number of the counter. So like the last number here, you can play around with this if you want to. And then the last argument in the rotate function is the number of degrees you're rotating. So for this, I'm just going to have it loop through 1 through 50. And then I'm going to use this function, pause, which is going to pause for half a second after each iteration of this loop. And then my last line of code is setting my axes so that they aren't changing with each loop iteration, which just makes things look a little bit less crazy when I'm running through it. Okay, so to step through, I'm going to define my direction variable, so we'll see that pop up in the workspace. And then I'm going to start going through my loop. And I think it's best if I just run the rest of this code. So I will run, I guess I'll step through a couple times so you can see. Okay, so it rotated a little bit. I don't know if you saw that. Oh, you know what? I'm gonna move this here. We'll do that. Okay. And then I'm gonna go through the loop again. Okay, so it's gonna rotate and pause. And it's rotating. I'm not gonna do this 50 times. So let me get to the end of my loop, and then I will run the rest of this code here. Okay, so you see it rotating over here, so it's just rotating around the z-axis. And it kind of seems like it's going the wrong way, but I think that just has to do with how often we're pausing the function. Okay, oh, I'll talk about that in a second. Okay, so the last thing I generated, so similar to, which lab was it? Oh, the one where we did the quiver plots. We're going to create a mesh grid of coordinate points, of xy points, and we're going to define a function z, which is related to x and y. X and y are the independent variables, and z is our dependent variable. And this is going to create a series of vectors, or a series of matrices for x, y, and z. And then you can just use the surface function to plot that 3D function to visualize it more easily. So that's what this one looks like, and I changed it from the default color into a different color map called winter. So that's pretty much it. So you can rotate these guys.